Okay, welcome everybody. I hope that you are having a wonderful afternoon so far. I'm just going to do a quick sound check on this speaking that I'm doing right now, and then we can get started. All right. Perfect. So it sounds like the sound is working out okay. And if at any point the sound starts to get wonky, feel free to let me know in the comments. I'm happy to try and fix it at any point. But without further ado, we're going to get started on today's grade 9 lesson. We're going to be talking about the unit called Rates, Ratios, and Proportions. This is not a huge unit in grade 9, but these are actually very important math skills. And in my opinion, this unit should actually be focused on a little bit more because it's one of the things that you really do need to understand for the rest of math. And for those of you who want to go on to the sciences or into the STEM fields, it's really important in every aspect of science. So yeah, anyways, let's get started. As you can see, I've got a question here. Now, first of all, let's quickly just, before we get started, discuss something that's really important in this unit. So, let me just fix this. Oh, there we go. When we talk about these couple different things, we have our rates. So when we think about rates, we can say, something along the lines of, well, kilometers per hour is a rate, right? It's really important that we understand that rates are how much part of a whole and sometimes it doesn't even go like that. Sometimes you can even say, well, we have a certain amount of something per something else. So like I said, kilometers per hour, that's a rate. Meters per second, that's a rate. It's really important to understand this and how it relates. But realistically, rates are typically going to be presented to you as fractions. And that's how you're going to recognize that you have a rate for something. Now, when we talk about ratios, that's something you probably learned in elementary school, but you have, x to y, right? And then lastly, proportions, you've got, proportions are similar to rates, but they're a little bit different. You've got part of a whole equals percentage out of 100. So we're going to talk a little bit about how everything relates, but before we get started, I want us to focus on this question here because it does give us a very good understanding of what it is we're trying to what we're trying to do in this unit. So I'm just going to erase those quickly. And for those of you following along, if ever you need to go back and watch parts of the lesson. Oh, apparently it's a little echoey. Let me fix that. Let me see if I can fix that. Give me 1 second, you guys. So please let me know if it's still echoey. Alrighty, guys. So when we talk about a ratio, here we say in this question, this one right here, we'll call it Q1. It says a grocery store has 700 pieces of fruit on display. The ratio of apples to bananas is 4 to 6. So how many apples and how many bananas are in the store exactly? Well, one thing I want us to understand that ratios work proportionally, and that's why this unit has all three of these things, because these things are very much related. So if I said that I have a ratio of apples to bananas, and it has a 4 to 6 ratio, I can actually reduce this because in the same way that I can reduce a fraction, the fraction would look like this. I can reduce this by dividing both by 2. And it's still going to operate in the same way. It means the same thing. And I'll show you what I'm talking about. So if I'm dividing both of these by 2, I get 2 out of 3. When I look at this as a fraction, and I'm going to just kind of draw, actually, I'm not going to draw a circle. I'm just going to bring myself a circle here because that'll be easier. So if I have this circle and whoa, let's just draw another circle. This circle and this circle. Let's pretend that they're the exact same size, okay? Let's just grab that. Okay, so I'm going to show you why this all makes sense, okay? So let's say I have my 4 to 6 ratio. I'm going to split this into 6 pieces. And I'm going to split this one into 3 pieces. So let us kind of break down how this works. I'm just going to change my pen color here so that we can see. So in the 4 to 6 ratio, pretend that these slices are perfectly equal because that's part of the issue. So let's say 1, 2, 3, 4 pieces are filled in here. Okay? And I'm going to do the exact same concept on the other circle. So here I'm going to fill in 2 out of the 3 pieces. As you can see, we're getting that filled in. Okay, so if we take a good look here, we can see that this is basically the exact same thing. And it not just basically the exact same thing, it is literally the exact same thing. And that's what's happening with all ratios. You can as long as you're multiplying both things by the same number, you're getting the same proportion. So because ratios are proportional, they can tell us a lot about bigger amounts. And I'll show you guys what I mean. So whenever I have a ratio that can be reduced, I'm going to always reduce it just for my own sake and simplicity. And let's just kind of move this to the side. Oops. Can't move that to the side, but that's okay. Now, let's take a look at this. So if I have apples to bananas and I have 4 to 6, 2 to 3, it stands to reason that as long as I multiply both things by the same number, I still have that same ratio. So let's say I multiplied both by 5, right? So 2 times 5 is going to be 10. And 3 times 5 is going to be 15. And again, if I was to do my fraction thing here, where I draw a fraction, then the actual amount would look the same. It's going to be proportional, meaning it looks the same. Okay, so keeping all of this in mind, let's find out how we solve these types of questions. So keeping this in mind, like I said, let's find out how we solve these types of questions. So if the grocery store has 700 pieces of fruit on display, and the ratio is 4 to 6, there are a couple ways that we can do this. I'm going to show you guys what I believe to be the easiest way. And that's actually using a little bit of algebra knowledge. So what we're going to do here is I'm going to say, okay, well, since this is a 2 to 3 ratio, and I know that 2 times apples plus 3 times bananas but X is going to represent fruit pieces. So if 2 times this fruit piece and 2 times this fruit piece equals 700, Then all I need to do is solidify this because these are like terms. So that's going to equal 5x, and that is going to still be equal to 700. And then I just algebraically solve for x. So again, we're going to divide off 5. Oops. Sorry guys, my phone just went flying. Give me 1 second. Okay. So then basically I'm going to get x equals 700 divided by 5, which is 140. So x represents 140 fruit pieces. So I'm going to now take this information, just move up slightly. I'm going to take that information and use it to my advantage. So this was step 1. We created a statement. And now in step 2, I'm going to take this information and use it to my advantage. So that means that I have apples to solve for. So let's find out how many apples. Well, we have 2 times 140 apples. So 2x equals the number of apples. And that means that I'm going to go 2 times 140, which is 280. And then I'm going to solve for bananas. Okay, there we go. Solve for bananas. And I'm going to have that equal 3 times x, which is the number of bananas. And that's going to be 3 times 140, which equals 420. Yay! Okay, you guys, so that means that we have 280 apples and 420 bananas. Okay, great. So if anyone has any questions about that, feel free to leave it in the comments. But just to kind of reiterate what it is that we're saying is going on here. When we have a ratio, it's actually also a proportion. It tells you proportionally how much of something there is in relation to something else. So because of that, we can always find out the exact amount. If you know one, you know the other. And you can do this for many different things. So we're going to do a couple more examples. Now, again, keep in mind the simplistic piece that really is important to understand. So we're just going to go to the next. If no one has any questions, I'm just going to open another page. So let's say let's use different colors to kind of illustrate. So let's say I had ratio of blue toys to red toys. And for every blue toy, for every 1 blue toy that I have, I have 5 red toys. So I'm using this type of example because it really does illustrate what it is that I'm trying to show you guys. In that when we talk about ratios, the ratio is true no matter what amount you're multiplying it by. The thing is, though, that you have to multiply both sides by the same amount. So let's see what that means. So if I said to you, hey, you know what? This is the ratio of blue toys to red toys. Always, always, always. It doesn't change. For every 1 blue toy, there's always going to be 5 red toys. And I said to you, hey, you know what? Actually, it turns out that this company has 4 blue toys. Let's put that in blue, actually. 4 blue toys. Can you solve for how many red toys the company has? And in fact, we can. Okay, guys, it's very, very simple, actually. And I'll show you how you can do it. So, all we need to ask ourselves is, how many multiples, or how many times did I multiply the one side so that I can multiply the other side by the same amount? So if I'm asking myself, what is 4 divided by 1? Well, that means the answer is 4, and that means I multiplied this by 4. So to be fair and to get the correct answer, I have to multiply the other side by 4 as well. So that means that I'm going to have 20 red toys in this scenario. Okay? So there are ways to do this. You have different examples that we're going to go through. And it's very, very important that we understand how we can switch between these things. Okay? So another way that you can solve this exact same question is by saying to yourself, okay, well, if my ratio of blue to red toys is going to be 1/5. Oh, let's do that in black. Then how can I solve for that same thing using a fraction? Well, right now I'm going to call the answer to this x because we don't know what it is. So I want to solve for this. Well, how do we usually solve situations like this? We usually would go ahead and do a cross multiplication. So I would cross multiply this up here, and I would cross multiply this over here. So that gives us x equals, or 1x, because that 1's still there, but that's okay because in algebra we always want to get it down to 1x. We've got 4 times 5, which equals 20, which is the right answer, as we can see. Okay? So whenever you get a ratio question, you can always set it up as a fraction and then solve for that unknown variable. And it works the other way as well. I could have said, let's say, for example, we didn't know, I'll leave that up for a second, but let's say, for example, we didn't know that we have 4 blue toys. Let's say we knew that we had 20 red toys. And then they're asking us, well, how can you solve for 4 blue toys? The situation is pretty much the same. It's just about setting it up correctly. Again, you are trying to say, on the one side, again, one ratio is one fraction. Okay, so if we have one blue toy for every red toy, for every 5 red toys, and then I don't know how many blue toys I have, that's going to go here in the numerator, just like the blue toys went in the numerator. And it doesn't really matter which you put where, as long as you're using the same numerator or denominator in the fraction equation. So it looks like this. And now I need to solve for this x, which is in the numerator, which is going to work like this. Again, we're going to cross multiply. So this is going to look like 20 times 1 equals 5 times x. And then all we need to do is solve for x by dividing off 5 from both sides. And if this is confusing you guys, I highly recommend going over your algebra because this is going to be very important for you guys to know. And then 20 divided by 5 is equal to x. Sorry, is equal to 4 is what I'm trying to say. So in this case, we solved it again. Okay. So, like I said, this is a very small unit in math. I don't know if every teacher even covered this year because of COVID, but it's actually one of the most important units for people to understand in math. Because if we don't understand this, there's a lot of stuff in math that will be very difficult for us. Okay. So I'll leave that up for a second if anyone has questions. So like I said, this is super important to understand. And if you have trouble solving ratios, it's definitely something I say that students should practice. So let's try another example that's a word problem. So I like to always start off the lesson with a kind of more difficult problem, and then we go and do an easier problem, just like we did right now, and then we go back to doing a difficult problem so that you can actually kind of see the disparity between how you would approach that in any situation. Okay, so I'm going to show you guys what I mean. So this is a very common type of question that you would get on the test for this unit. So let's go ahead and read that together. I hope you guys can see it. I'm just going to try to make it a little bit larger. The measures of two acute angles of a right triangle are in the ratio of 2 to 7. What are the measures of the two angles? So a right triangle, as we know, looks like this. It means that there's a 90-degree angle there. So that's 90 degrees. And I know that a triangle always is going to have 180 degrees between all three angles. So all three angles have to add up to 180. And what we're saying is that the measure of the two acute angles, so this angle and this angle, is in the ratio of 2 to 7. So we want to know exactly what those angles are. And we can definitely solve for that. So whenever I get a question like this, the first thing I want to say to myself is, okay, well, what do all of the things add up to? So I know that 180 equals, in this case, 90 degrees plus 2 times some degree plus 7 times some degree. And we're going to let x represent the degrees of the ratioed angle. So again, if the ratio of the two angles is 2 to 7, then the measures of the two angles can be written as 2x and 7x. Because again, anytime we're solving for something like this, we know that it is a proportion, and we also know that that is an unknown variable. So we can approach it like an unknown variable. So let's go ahead and kind of work away here. So I know that I still need to simplify this on some level because I have to move 90 over so I can get solving. So it's going to be 180 minus 90 equals 2x plus 7x. On this side, this is going to simplify to 90 degrees. And on this side, this is going to simplify to 9x. And then I can go ahead and solve for x by dividing off 9 from both sides. So that's going to cancel on the right side. On the left side, 90 divided by 9 is 10. So the base angle equals 10 degrees. Okay, so let's take that information. So this was step 1. Actually, this is step 1. Creating a let statement is step 1. Step 2. Here we are. And then now we're going to move on to step 3, which is using that information to solve. So if I know that we'll call this angle A, so angle A is 2x. So then I can just take this information, because I know that x equals 10, and I will say this is 2 times 10, which equals 20. And then angle B, which will be this one, is 7x. So that's going to be 7 times 10, and that's 70. Okay, guys, so if anyone is confused at all, feel free to leave a question in the chat. But I'll leave that up for a second. And basically, for a question like this, because it's a word problem, you're going to want to solve it with a word answer at the end, something along the lines of like the measures of the two angles are 20 degrees and 70 degrees. Okay? Wonderful. Okay, you guys, we're going to move on to the next question. So we're going to do one more question like this before moving on to our percents and ratios. Okay, so we've got a jar filled with, actually, you know what, I don't want to confuse you guys, so we're not going to do this jar question. So a rectangular field, this is a very common type of question that you'll see. A rectangular field has an area of 300 meters squared and a perimeter of 80 meters. What is the ratio of the length to the width of this field? Okay, so if you're following along, I highly recommend writing this one down and following the steps I'm about to show you, because this is a very common type of question, and it's really, really important to understand these types of questions. Okay. So first of all, let's talk about what we know about so far in this question. We know that the rectangular field has an area of 300 meters squared and a perimeter of 80 meters. Okay, so let's first draw our rectangle. Let's see if we can turn this. There we go. Cool. Great. We've got that. So I know that the area of this equals 300 meters squared. And if we know anything about our area situation, it is that the area equals the length times the width. Okay. So in a rectangle, we have four sides, obviously. So we have two lengths and two widths. And that's how we can solve for our perimeter, because we know that the perimeter of a problem like this, or of a rectangle is what I'm trying to say, is 2 of the lengths plus 2 of the widths. Wonderful. So it's very, very important to understand this, you guys, and it's really, really good to practice these types of problems, because at the end of the day, the more that you practice, the better and easier it's going to be for you. Now, keeping all of this in mind, we also can plug in some numbers here. So I know that the area is 300 meters squared, putting in my units there, and the perimeter is 80 meters. My number one suggestion for word problems, you guys, is just to always follow the guessa method, or the guess method, whatever you want to call it. So we start with what's been given. We ask what's the unknown. We say what is the, what's this word? Oh, I should be putting an E there, gosh. What is the equation that we're going to use? What is the solution? Oh, sorry, we're going to solve first and then we're going to do solution. Solve, solution, and then the answer. If you follow these steps that we call GESA, trust me, all of the rest of math will be so much easier for you. So first we're saying what's been given. Here we know that this has been given already. This is our G. What is our unknown? Our unknown is that we don't know, here we should say let L rep length in meters and let W represent width in meters. So next what we're going to talk about is the fact that we don't know the length and the width. We're trying to solve for both. Great. So what's the equation we're going to use? Well, we're going to go ahead and solve using these equations, and we need to rearrange these in terms of one single thing. Okay? We have to put it into their simplest form. So let's go ahead and change this into something. We've got length times width equals 300. And we're going to change this into all in terms of length. So I'm going to say length divided by width, because that's how I'm going to cancel out the W, equals 300 divided by width. So that means length equals 300 divided by W. And I can plug that in to my other equation. So if I go over here, because length and width would be the same in either equation, because we're talking about the same triangle, my other equation is 2L plus 2W equals 80 meters. I can now take this information, and instead of saying L, I'm going to say 2 times 300 over W plus 2 times W equals 80 meters. We're just going to say 80 so that no one gets confused. Okay, so let's keep on trucking. Now, here we've got this situation. I need to solve this, so it's going to be 600 over W plus 2 times W equals 80. And what I'm going to do here is some fun solution stuff. Actually, I'm realizing this problem might have some grade 10 pieces to it, so we might just skip the end, like the ending, but this is kind of the setup that's really important. So in this case, we actually would go ahead and multiply this whole situation by W to get this W out of the denominator, which is something that we've been talking about in previous weeks. So if you missed out on the solving with algebraic solutions, go back and watch our old videos so you can take a look at that. So I'm going to multiply everything by W so that I can cancel out the W in the denominator. So this is going to be this times W. Okay. And then we're going to go ahead, that's going to cancel. This is going to become 600 plus 2W squared equals 80. And then we just solve algebraically. So we go 2W squared equals 80 minus 600. And then that's going to be 2W squared. Sorry guys, my allergies are acting up. Equals negative 520. And we can solve by dividing 2 off of both sides. So we get W squared equals negative 260. And then because this is negative, now in this case, because we're approaching this from a situation where obviously it's a real thing, we don't need to worry about that negative. So anyways, we're going to leave this for now because I'm realizing that this is a grade 10 concept. I don't want to confuse you guys, but just the main part of what I wanted to show you in this question was really the understanding of how we set these up and how we go from here. Okay? So I'm going to leave this. We're not going to finish this question because I don't want to confuse you guys, but really just understanding how we approach these is very important. Okay? Okay. So, now we're going to talk a little bit about percents. So, as you know, just from years of getting your test marks, right? So say you had a test that was out of 20, right? When you're getting your test marks, say that you got 17 because you studied really well and you got a good mark. Well, that means that you got 17 out of 20. But we all know that that's not really going to help us solve for what the percentage is on your marks. So typically in this situation, you'd go to your calculator, you press 17 divided by 20, and you'd go like that, and you'd get 0.85, and then you'd multiply that by 100 to get the percent of 85%, which means you did very well on that test. So when we talk about what percentages are and how we use them as proportions, you can use proportions to solve percent problems. Okay, so if we have part of the whole equals percentage out of 100. And I'll show you guys what I mean. So you can solve any percent problem using this proportion, and you can use it to find the percent, the part, or the whole. So I'm going to show you what I mean. So if I said to you, find the percent 84 is what percent of 96? Well, again, this is one of those problems, just like how you would solve your test mark. You would say, well, the is part of 84 of the whole means that the percent is unknown, and the percent is always over 100. So it's going to be like this. 84 over 96 equals some unknown variable x over 100. And then you can go ahead and solve for that. Now, the way we solved for it here was it had a step where we said basically, okay, well, we'll do this division and then we'll multiply it by 100. Well, let me show you how this makes sense in the same situation that we would do here, okay? So in this situation, we're going to cross multiply like this. So we get 84 times 100 equals 96 times x. So 84 times 100 is 8,400 or 8,400. And on this side, I have 96x. And again, like I've been saying, guys, if you have any struggles with these types of questions, it's important that you practice algebra to the max. Algebra is the basis of all of math. If we don't get really good at doing algebra, we will struggle with the rest of math. So now I'm going to isolate for this x, and by that I mean I'm going to divide 96 off of both sides. So 96 divided by 96 is just 1, which is what we're looking for. And then x is going to be 8,400 divided by 96. 87.5. Okay. Now, that's one way that I solved it, right? And it's not necessarily the way that you might be used to in math class when you're solving for a test mark, but it gets the same percentage. So if I was to do the concept that we did before where I said, okay, well, what's 84 divided by 96? That's another method I can use. And I get, actually, let me write that out for you. And I get 0.875. And now I need to multiply this answer by 100. Well, why am I multiplying it by 100? Well, if I had it set up like this again, 84 over 96 equals x over 100, then even if I solve for this part, I'm still left with x over 100, so I have to multiply that over here to solve for it. That's really what's happening. That's how we get 87.5%. Okay. So I'm going to leave that up for a second, and then we'll do another question that gets a little bit more complex. Okay. Alrighty, you guys. So, let us keep on trucking to another problem. So remember that the formula that we should always use is that the part of the whole is equal to the percent of 100. This is something that I want you guys to really ingrain in your minds as being the number one thing you got to remember. Okay? So if I said to you, find the part, and I asked you, what is 25% of 92? So let's set this up. Let's ask which part is which. So we have a percent. Right? And then this has been told as being the whole, because we know that when we say of, that indicates that this is the whole. Okay, so let's go ahead and use this information to our advantage. So again, let's set this up the way that we know is best. I always recommend rewriting your equations. So this is our equation. Let's put the pieces that we know into the equation. So I don't know what the part is. This is my unknown variable, so I'm going to leave that as it is. I still don't know what part 25% of 92 is. So I'm going to leave that. But I do know that the whole is 92. And on this side, I have my fraction, which represents the percentage. So I know that I'm looking for 25% over 100. Okay? So let's go ahead and do some plugging in here. So I'm going to rewrite part as the letter X. Great. So again, the letter X just represents that we have an unknown number there. We don't know it yet. So there's two ways to do this. You can either go 25 divided by 100 times 92, or you can do a cross multiplication and a division. I find doing this part like this, where we solve 25 divided by 100, which is 0.25, and then you just go ahead and cross multiply this out of the denominator. So we get x equals 0.25 times 92, which is going to be 23. So 23 is 25% of 92. And I can check that my answer is correct by acting like this is a test mark, as you would if you got your test back and you said, hey, I mean, God forbid, no one wants to get 23 out of 92, but let's just say hypothetically someone got that. So let's say someone who did not study got 23 out of 92, and I was to put that into my calculator, 23 divided by 92 times 100, and that's 25%. Okay, so if anyone has questions about this, let me know in the comments. Okay, I'm not seeing any comments, so we're going to go ahead to the next question, you guys. So now we're going to do another example. Again, I want to rewrite my equation. So the part of the whole, when you see of, that means you know that that's the whole amount that they're talking about, equals the percentage out of 100. This is our standard equation. Say we want to find the whole, and we say 15 is 75%. Actually, let's use different numbers. Let's say 27 is let's say 30, well, let's fix that. 27 is 32% of what number? Well, we can definitely solve for that. And the way we do that is, again, setting this up. So let's represent what each thing is by first walking through the question. So 27 is 32% of what number? Whenever I see the letter, the word is, that means that this is the part. Okay? And this here is my percent. So if I rewrite my equation, which I highly recommend you guys do, so I have part of whole equals percent out of 100, we get to plug everything in. So 27 is the part. I don't know the whole. And I do know my percentage, which is 32. And 100 always stays there. It's the standard part of the equation. So now all I have to do is rearrange. So I'm going to change the word whole to be x so that we can solve this algebraically. And I'm going to get my percent amount here. So I'm going to get 27 over x equals 0.32, which is our decimal. Sorry, I meant to say decimal. Then I'm going to solve this algebraically. So I have to multiply this up. So we're going to go ahead and get that answer. So we're going to go 27 equals 0.32 times x. And we're just going to solve for x by dividing off 0.32 from both sides. So actually, 27 divided by 0.32, it's going to be some bigger number. So x equals 84.375, which I'm going to round to be 84.4. Yay! Okay, you guys, that's wonderful. So I'll leave that up for a second. So let's take this up a notch. and do a word problem like this. Okay, so let's type it out here. It's now worth, let's say, $7,500. Should put that dollar sign in the front there. Oh. Which is 40% of what he paid for it. What did he pay for his tractor? Okay, so a couple things we want to note here. First, I'm going to make this large enough so everyone can see. Great. Alrighty. So what are some things that we want to think about here? Again, as soon as I see a question type like this, the first thing I want to write down for myself is our equation. Part of whole, so this is part of a whole equals x over 100. This is my standard equation whenever I have proportion problems like this with percentages. Great. So I've created my situation here. Now I want to re-ask myself, how can I rearrange this question? Well, they're basically saying 7,500 is 40% of what number? Well, we've been doing a lot of problems like this, so we can definitely apply this to what we want. So again, we need to first isolate and determine what each thing means. So 7,500 is the part, because it's part of what the whole amount was in the beginning. And 40% is my percentage, obviously. So let's plug that in. So if I've got 7,500, oh, let's rewrite the equation actually. I just did the same thing again. I've been trying to do this. Part of whole equals x over 100. So in this case, it's 75 over the whole equals 40 over 100. Okay guys, simple enough. We can just go ahead and do some solving. And we're going to get this part first on the right. So we're going to go and leave this. I'm going to turn whole into x there. So this is going to be 0.40 because 40 divided by 100 is 0.40. Then I'm going to move the x up to the other side algebraically. And I'm going to solve for x by dividing 0.4 off of both sides. And that's when I get x equals 7,500 divided by 0.4, which is going to be 18,750. So that's what his tractor was worth when he first bought it. And that is a lot of decrease in value. And I want you guys to know that that's true for most vehicles. A car is the worst. A car, tractor is a little bit different because they use that, farmers use that as their business. But I mean, if you're just buying a tractor for fun or any car for fun, they decrease in value big time, and it's a terrible investment as far as money goes. Okay? But that's neither here nor there. This is the answer to this question. We're going to take a look at another type of word problem for this whole unit. Okay. So let's take a look here. We've got, oops. Susie needs $12,000 to buy a car. So far, she has saved $7,000. Oh. What percent of the price of the car has been saved? So this isn't too hard, but it's an important question type for us to understand. Okay? There we go. Oh my gosh. There we go. Finally. Got it. So if she needs $12,000 to buy the vehicle and she's already saved $7,000, how much has been saved? Well, we can definitely solve for that, because this is just like finding out what mark you got on a test. But we always want to rewrite our equation. So the part of a whole is equal to x over 100. And that's how we get this. So this is the part she's saved. This is the whole amount that she needs to save. How much of the price has been saved as a percentage? So let's go ahead and plug stuff in. So if I've got 7,000 in the numerator and 12,000 in the denominator, this part stays the same every time. I'm going to get 7,000 divided by 12,000 equals 0.58. Another way we could have solved that is actually 70 over 120. It gives you the same answer, because those zeros cancel. But that's neither here nor there. And then we've got, so actually one thing to note, why don't these zeros cancel? Because they're not in the same place, right? 70 is, the 0 is in the 10 spot, and 120, the 0 is in the 1 spot. Like is in the 100 spot, sorry. Okay, so anyway, 0.58 equals x over 100. So then we get 0.58 times 100, because I'm multiplying that up, which equals 58%. Yay! Okay. So there's that, you guys. Let's see if we can do one more question really quickly. And again, this is a really important unit, and I really highly recommend you guys practice this as much as you can. So let's say someone, quickly before we have to go, someone says, what is 50% of 7? This seems really simple, but I'm going to show you guys why. Actually, let's do 50% of 6. So this is the same thing as saying, what's half of 6? And we know that that's 3, right? But what we need to figure out is using our equation, because it's not always going to be this simple. So what I recommend with math in general is have a base understanding of something using very simple numbers, and then apply it to a more complex question. So if I don't know, they're asking for the part here. What is the part of 6 that is 50% of it? So if I don't know the part, and I can go part over 6 equals 50% over 100. And then all I have to do is get 50 divided by 100. So I'm going to make part into x there. 50 divided by 100 is 0.5. And then we do this multiplication. And we get x equals 6 times 0.5, which is 3. Okay. So hopefully that makes sense for everybody. That's the last part of this unit that we're going to work on today. That's the last part of our hour here. And I hope everyone found that helpful. If you have questions that you want us to answer next week, you can email them to us. But that's everything for today. So I hope you guys are well, staying safe out there, staying healthy. And I will see you again next week. We've only got 3 more weeks of math help. 2 or 3. I need to look at the calendar, actually. I'm not 100% sure. 2 or 3 more weeks. Definitely 3 more, for sure. But anyways, that's that. And I would like to welcome our grade 10 class today. So I'm just going to grab my grade 10 materials here. Alrighty. So, hope you guys are having a great day so far. Welcome, welcome if you are part of the grade 10 class. First and foremost, I want to mention that I hope you're having a safe day so far, a healthy day. And as well as that, I want to remind everyone that right now in the grade 10 class, we are working on sine and cosine laws. And today we are culminating that unit and working on word problems for that particular unit. Okay? So, keeping that in mind, let's get this party started. And we'll go from there. So here we are. If we've got this question. So remember, actually, before we get started on any questions, we want to talk about what are the sine and cosine laws. The sine law is this law where we have, for triangles that are non-right angle triangles, we can say sine of angle A over length A equals sine of angle B over length B equals sine of angle C over length C. So that's the sine law. And then our cosine law is A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A as it relates to the side length A. Alrighty. So this is very important to remember. We are going to be rewriting these, so no worries at all. But I just thought we'd go over that quickly. So these are for non-right angle triangles. Okay? Great. Perfect. So keeping that in mind, we've got non-right angle triangles. That's really important. And what we're going to do now is focus on how this information can be used in a real life context. So most of the time, the more mark-worthy questions that really are going to get you those highest marks on tests and quizzes and stuff are going to be using cosine law and sine law as word problems. So let's go ahead and do that. So let's just type this in really quickly. Oops. 1 second, you guys. So I'm going to add my text here. So from a prison watchtower, there are 2 floodlights lighting the prison yard. The triangular shaded region in the given diagram, which I'll show you guys the diagram in a second. Actually, 1 second, you guys. Just want to make sure of one thing. Question. Okay. So there are 2 floodlights. Sorry, I just wanted to make sure that we were looking at the right thing. Back to this here. Give me 1 sec. I lost my page here. Okay. Yeah, given the diagram below, represents, well, let's do a thing here. Represents the section of the prison yard that is lit by the 2 floodlights and has an area of 670 meters squared. And then the question we're answering is if angle ACB, which I'll show you what I mean as soon as I draw the diagram for you guys, equals 98 degrees, and the length of side BC is 84.51 meters, sorry, then the height H of the shaded triangle that represents the section of the prison yard lit by the floodlights to the nearest meter is what? Okay, so let's fix this real quick. Oh, I hate when it does this. Anyways, we're going to just do this so that you guys can see what I'm talking about, and then we'll bring it back in a second. Okay, so let's draw our diagram here. I'm going to get my triangle situation here. So let's say this is that triangle, and it looks something like that. Oh, let's move it over. And then within this triangle, there's another triangle. Oh, that's not how one should draw it. Why is it upside down? You know what, I'm just going to draw it freehand. See how that goes. And I just need a straight line here quickly. Okay. So, let's get all this in order here, and then we are all set. Okay. And then I've got this. So if this is there. Oh. Trying to get these straight lines, you guys. There we go. Okay, so this is my shaded region. This here. This whole area. Shaded. The shade. I love when kids say that. Okay, so this is going to be that. So the prison watchtower, if these are the floodlights, which let's take this whole section here and make it bigger, just so everyone can see what I'm talking about. Okay. That should be a straight line as well. Okay, so we've got floodlights. Let me write that a little bit nicer. I promise we're almost done setting this up, you guys. I just want to show everybody what we're talking about. So if these are the floodlights, and I'm going to erase this shade because it's confusing to people. But this is going to be the shaded region, okay? So just keep that in mind. Cool. This here is a 90-degree angle. That's important. So we've got shade for shade. Okay. And then we've got these here. So this is also with a 90-degree angle. This is C. This is also with a 90-degree angle. You can't really tell, but it's there. And then this is the prison watchtower. And that's 21 meters. Obviously, this diagram is not to scale. So this here is 19 degrees. Okay, so this is angle B, this is angle A, and this is angle F. Okay. So let's go ahead and start solving this problem. First, we're going to determine that in this situation, let's pretend that we are not allowed, that we have to use the sine law. Okay? So when we're doing problems like this, it's really important to determine your method of attack before we do anything else. So you have to determine whether sine law or cosine law applies, and then you can go from there. Okay? So, keeping this in mind, we need to first determine the distance from point A, which is here, to point C, which is here. And point C in the right triangle, FAC, goes as follows. So we have FAC. So this triangle here. And we know that this is a right angle in there, even though it doesn't super look like one. It's very important to remember that. So if we're looking at angle FAC, And I know that tan of FAC is equal to this length, FC, from here to here, over FA, or sorry, AC. So why is that? So if I'm talking about angle FAC, that means that I'm talking about the 19-degree angle that's right here. Okay? So if I'm saying tan of 19 degrees, in this case tan, or in any case, tan is always opposite over adjacent. And in this case, the opposite is the angle, is the side length FC, and the adjacent is this side length. Okay, so let's go ahead and use this information. Now, in our initial problem, we have been given the opposite length. We've been given 21. I've kind of hidden it by accident, but this is 21 meters. The actual watchtower is 21 meters long. Over some adjacent that we don't know. So again, tan of 19 degrees in this situation is 21 over the adjacent, which we don't know. So how can we solve? All we have to do is a quick cross multiplication, and we get tan of 19 times x equals 21. And then you divide off tan of 19 from both sides. And then we get x equals 21 divided by tan of 19, which is 60.99. Okay, approximately 60.99. So now we know that angle AC, side length AC, because if I'm looking at this triangle like this, and I've got my middle triangle like this, and I'm looking for this side length, I now know that this side length is 60.99. So this is 60.99, this is 21. We still don't know this, but we could solve for that. So next we need to determine the distance from point A to point B by applying the law of cosines. And the way that we can do that is very simple. So let's take a look here. I'm just going to do a little bit of erasing. Great. Erase that, erase this. Okay, let's do some law of cosines here. So if I'm talking about the distance from angle the length of AB, right, and I'm using law of cosines, there are a couple things I need to keep in mind. The law of cosines in general is a squared equals b squared plus c squared plus 2bc times cos of a. When you have a complex question like this, you need to sit down and ask yourself, what does everything mean in this particular question? So in this question, we're actually solving for a side length AB. So I'm going to create a little chart here. So my little legend, A equals side length AB. B is side length AC, this one. Ow. C is side length CB or BC, whatever you want to call it. And then angle A is across from that there. Okay. So let's keep all of this in mind and start using some information that we know. Okay, so let me just move this over and delete that. Okay, so in this case, we're going to have angle AB squared equals, side length AB squared equals side length AC squared plus side length BC squared. Again, I'm just substituting based on my little legend that I've created for myself. And you should always create one of these for yourself in scenarios like this and make sure that you're always using the correct substitution BC times cos of A. So do I know side length A? Sorry, the angle A. Well, if we have substituting 60.99 for AC, 84.51 for BC, because we already had that information. Where did it go? It's up in the beginning. Yeah, the side length of length BC is 84.51. Wonderful. And we're going to substitute 98 degrees right here. Let me just make sure that we've got that part there. Yeah, actually we were told that in the question. Angle ACB is 98. It's just hidden here. Okay, so we can go ahead and plug everything in. So again, I would write down all the information that I know. So I've got, where did it go? Over here, I'm going to write this over here. AC equals 60.99. And we know that BC equals 84.51 because the question told us that. Angle ACB. And remember, the first letter in the angle situation is always the one that's where it starts. Okay. Great. So that's going to be 98 degrees. And we're just going to plug all that information in. So I still don't know what side length AB is because that's what I'm solving for. So I'm going to leave that like that. AC is 60.99. And again, these look a lot more complex than they really are, you guys. It's all about making sure you're plugging things in properly. Do not rush through these types of problems, okay? And actually, I shouldn't even put brackets around that because it's not negative. So 60.99, or you know what, because some people find it confusing, we will put brackets just so you don't get confused. Okay, let's plug everything in here. 84.51 squared plus 2 times 60.99 times 84.51 times the cosine of 98 degrees. You can do it like that if you want. Technically it's this and then square. Anyways, not going to confuse you guys. So let's get these numbers. 60.99 squared, because again, we always have to follow BEDMAS, you guys. So 60.99 squared is 319.78 approximately. 84.51 squared is going to be 7,141.94. Then all here, we're going to go ahead and do this part. So I always say start at the cos 98, so get cos of 98 first. It's going to be negative, but that's okay. Then you multiply that by 84.51, multiply that by 60.99, and multiply that by 2. So you have, oh, this should be a negative. I keep writing this wrong. This part here. Let's just put the in properly. Minus. Sorry, guys, I was writing the cosine law wrong. But anyway, so this is now negative minus negative 1434.67. And then as you know, a negative times a negative becomes a positive, so that's just going to become plus that. Okay, so keep on trucking here. So now we just add these three up. It's going to be approximately 12,296.39. And now, because this is equal to a squared, we want to get the square root, because remember, this is AB squared. So we are going to square root both sides. So we're going to square root AB squared and square root this side. And we get AB equals 110.89, approximately. So that's why I'm going to put my little squiggles in there. AB is approximately that. So we're still not done though, because what we're really asking for is the height. And if we look back here, what we're really asking for is this height. So if we remember that the area of a triangle is given as, next step, area of triangle is equal to base times height divided by 2. Therefore, for triangle ABC, if we know that the area, which is represented right here, is AB, which is the base, times the height divided by 2, and we've already been given the area as 670, so we're going to substitute that in. So 670, oh sorry, 2,670. Let's double check that. No, it's just 670. So 670 equals AB, which is 110.89, times the height divided by 2. Then we just go ahead and solve for height algebraically. This becomes 2 times 670 equals 110.89 times the height. And then we get sorry, I'm just trying to make sure that everything is good. So then we get 2 times 670, which is 1,340, divided by 110.89 to isolate for the height, because we're dividing it off of both sides. So we cancel. So then we get this 1,340 divided by 110.89. And the height is equal to 12.08. And then you're all set. Okay. Sounds great, you guys. So that's that. And then this is in meters, so the height equals 12.1 meters. We're just going to round that. And that's our answer. So that is this pretty crazy problem. And hopefully that was helpful for you guys. So I'll leave that up for a second. If anyone has any questions, just let me know. I just had someone send in a max value question, so we're going to do that quickly, and then if we have time, we'll come back to this. Okay, guys? So the question that was sent in, and again, for those of you guys who might be new, you can send us questions to our email address, admin@scholarlyelite.com. Let me just move this over quickly. Oops. So the max, what is the maximum value of the graph of the quadratic relation, and then I'll write the relation. Let me just move this up, make this larger. Okay, so the question that has been given is f of x
equals -2x squared plus 8x minus 19. Okay. So as we take a look here, basically in this question, we are going to approach this using the method of, let me just move that up there. The completing the square method. There are two ways to do it. I'm going to show you both ways. Okay, one is an easier way, and one is a harder way. I'm going to show you the easier way first, and then we'll do the harder way, because both are valuable to understand. Okay. So first and foremost, when we talk about quadratic relations, if we have this like this, and the setup is a quadratic relation is in the format of ax squared plus bx plus c. This is in its quadratic form. Okay, so if I was to apply that to this situation, it's f of x equals ax squared plus bx plus c, and then I can describe the letters as follows. A is equal to -2, b is equal to 8, and c is equal to -19. Because remember, they relate to the sign is in front of them. Okay, so keeping this in mind, there actually is a way to solve this without doing the whole completing the square, and that is by finding the absolute middle. Okay, and we call this the axis of symmetry. Great. So, keeping this in mind, what we're going to do now is use this equation for the axis of symmetry. So the axis of symmetry, when we're talking about a quadratic equation, let's say we're talking about an actual quadratic equation of x squared, then the axis of symmetry, if this is the y-axis, this is the x-axis, the axis of symmetry is at 0, x equals 0, because it's right here. Okay, but to solve for another problem where it's obviously not just the x squared, we have to use something a little bit different. So the axis of symmetry equation is x equals -b divided by 2a. I would really recommend just soldering this into your brain. It's super important, you guys, okay? And what we want to do here is determine this axis of symmetry, and then we're going to plug it back in to get the y, but we're just solving for the x right now. So if x is equal to -b divided by 2a, then all I need to do is plug in -8, and remember, 8 was positive here, so I'm plugging in 8 as it is. If 8 was negative, this would have been -8, but because of it being positive, it just is -8 right now. And then times 2a, so 2 times -2. And our axis of symmetry here, it's going to change into this. And then it's going to be 2, because those negatives cancel, and it's just 8 divided by 4, which we all know is 2. So that's the x value. So say we have like a, in terms of our coordinate, that's the x value. We need to solve for y, and all you have to do now is just plug in 2 into that equation that we were given in the beginning. So if f of x equals -2x squared plus 8x minus 19, then this is -2 times 2 squared plus 8 times 2 minus 19. And the x value here, sorry, we need to plug everything in so before we get the answer. So we get 2 squared, which is 4, times -2, which is -8, plus 16 minus 19. So this is going to be 8 minus 19. And we're going to get, -11. -11. So the y value here is -11. Okay, so we figured that out. The maximum value of this graph is 2, -11. We use this with the axis of symmetry equation method.
Now we're going to solve it the other way. Okay, so let's go ahead and actually I'll leave this up for a second and then I'm going to erase it so we can solve it the other way. And if you guys missed this lesson, it's on our YouTube page. If you go back to the previous grade 9-10 class, you can just zoom into the grade 10 class and take a look at that lesson. Okay, so we're going to erase that now. Give it a quick old erase. And then we're going to solve. So let's take a look here. So what we're going to solve now is using the completing the square method, which we have learned a bunch of times, but I'm always happy to answer people's questions. So if you guys, again, if you ever have questions, just because we're working on sine and cosine law today doesn't mean that we won't answer questions, because that's really the whole purpose of this, is to answer stuff live for you. Okay, so let's take a look here. Now, the maximum value of the graph of the quadratic equation. So we need to go ahead and solve vertex form, because right now, as we mentioned, this is in our quadratic form of ax squared plus bx plus c, and we want this in vertex form, which is f of x equals a x minus h squared plus k. So how do we do that? Well, first things first, we want to exile the c term from the island. The c term is negative 19, so this is going to look like this. Negative 2x squared plus 8x in the brackets minus 19. And the next thing we're going to do is remove negative 2. I mean, not remove it, but divide it out. So in this step, it's going to look like negative 2 x squared divided by negative 2, positive 8x divided by negative 2. But we don't do that from the negative 19. Only the stuff that's in the brackets, okay? So that means that we have to put negative 2 on the outside of the brackets, because obviously we divided it out. Negative 2 divided by negative 2 is 1, so that's great. Positive 8 divided by negative 2 is negative 4x minus 19. Okay, so now that we have this situation worked out, the a term has been removed and the c term have been removed in their own ways. We are going to take this term into what I like to call the death box. So in the death box, we remove the term in its entirety, which means here it's negative 4, it's also going to be negative 4 over here. That's very important, you guys, okay? Next, we're going to multiply this by a half. This is what I call chopping off its head. And we're going to get negative 2. Then we take negative 2 and we square it, which means we times it by itself. And that's going to equal 4. So from this point, we're going to take 4 and bring it back into this equation as both a positive and a negative. It's going to look like this. Everything else stays the same. The negative 4x does not change, but we add this in. Positive 4, negative 4. And we might do another example, because I actually hate examples where the number that you plug back in is 4, because I used to find that really confusing as a teenager. So we're going to probably do another example. But anyways, you take this number as it is, positive and negative in here. Great. So now that we've got this situation, we want to keep this part inside the brackets, but we want to take out the negative term, okay? So let's go ahead and do that. So the way that that works, though, is when it leaves, it has to pay its price. And by that I mean you have to multiply it by the a term, because technically we divided the a term out of everything. So if we're taking something outside of the brackets, we have to multiply that by the a term. So in this case, we're multiplying negative 2 times negative 4, because we're moving this negative 4 outside of the brackets. Okay, so that's going to leave us with this negative 2, which stays where it is. Just because we're using it doesn't mean we're changing where it is. Inside of the brackets, you're keeping everything, including that positive c term,
And over here, negative 2 times negative 4 is positive 8. And that's what we get that. Great, so if you remember how we got the answer last time, this is looking very familiar. Now, we want to turn this into a perfect square. And the way that we do that is by using the first number that we got in the death box. Okay, so the a term stays where it is, and this, instead of being an expanded form, is going to change to x minus 2. Which makes sense, because if I had x minus 2 squared, I'll show you an example here. X minus 2 squared is the same thing as saying x minus 2 times x minus 2. And if I'd use my FOIL rule, x times x is x squared, x times negative 2 is negative 2x, negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. So we get that perfect square. So this is just another way of saying this. It's the same thing, you're just saying it differently. And then positive 8 minus 19 is negative 11. So as you recall, our last answer was that the maximum value for this quadratic equation was at 211. Well, that makes sense because we are now in vertex form, which vertex form looks like this, if we recall. And in this case, and in every time we do something like this, we always use the opposite sign. So if this was negative 2, in the answer for the vertex, it's going to be positive 2. And that has to do with the fact that the standard equation is negative h, okay? But we're not going to get into that too much. Just remember that rule, that this is negative 2. Excellent. And then this is going to be positive 2. And then, but this stays the same, negative 11. So here it stays negative 11. I cannot stress enough that this is something that you have to practice in order to get good at. You cannot just watch me do it and automatically know how to do this. It's something where you're building a muscle memory in your brain. And it's very, very, very important that you practice this yourself. It's the same as, you know, practicing your three-point shot. You cannot watch LeBron James practice his three-point shot. And I'm not comparing myself to LeBron James, but you guys get the point. That you can't just watch a famous basketball player do his three-point shots and automatically be good at doing them. You have to practice it yourself. If you don't, it's going to cause you problems. I find that a lot of people in math class get discouraged because they don't know how to do things right away, because people have been taught their whole lives that you're either good at math or bad at math. But that's not the case. You have to practice it to get good. Alrighty. So, keeping this in mind, we're going to try another example like this one, because I find that these are not always the most conducive to learning how to do the step-by-step. Okay. We're going to use a fraction one. I'm just going to start a new page here. If anyone has any questions, feel free to drop them in the chat, okay? So let's say you get a question like this, and I have seen stuff like this on exams. I know you guys don't have exams this year, but this is something you'll see even in grade 11. You have to know how to do this. So let's say I told you that you have 5. I'm making this up, so don't expect this to be like a perfect situation. So plus 7x minus 20. Okay, so in this scenario, what we want to do is, again, exile the C term, starting off there. And again, we're solving for vertex form. So I've exiled my C term, and now I want to divide out the A term. So in this step, I'm going to show that. So 5x squared divided by 5 plus 7x divided by 5 minus 20. It's very important to remember that you're not going to put a decimal here. You're going to leave it as a fraction. So it's going to look like this in the end. So 5 is in the front. 5 divided by 5 is 1. So that's just x squared. And here I'm going to leave this as positive 7 over 5x minus 20. Okay. Now, just like before, we're going to take this, put it into our death box. In the death box, it's going to be the same situation. And that's why I believe in doing times a half. Some teachers teach this as divided by 2. It's more confusing that way. Just memorize, I meant to say, that this is going to be whatever term you take out of here, including its sign, times 1 over 2. It's the easiest way to do this. So in this case, we get 7 over 10, and then we take 7 over 10 and square it, which is going to be 49 over 100. I'm going to take that information and plug it back in. So we're going to get this as a positive and a negative. So we've got this here. Plus 49 over 100. Minus 49 over 100. Minus 20. Okay, so remember again, we want to move the negative out. But we can't just move it out as it is. We have to multiply it by the a term that we took out. So I'm going to practice that over here. 5 times negative 49 over 100. There's a couple different ways you can do this. You can like reduce this. You get 125. You know, it doesn't really matter. So I'm just going to go ahead and plug that into my calculator. Oh, sorry, not 5. This is 20. My bad. That's 20. Because I'm dividing it by 5. So 49 divided by 20. So this is going to be negative 2.45. In this case, I might just leave it as a fraction. You don't have to. You can do this. It can even be like this. However you want to place that. Basically, I'm going to leave it as a fraction. So 5x squared plus 7 over 5x plus 49 over 100. And then here it's going to be negative 49 over 20 minus 20. So I like to tell people, like, obviously it's really up to you. In this case, I would say simplify the brackets quickly before you do the outside part. So again, you're just taking this number, the first number you got as the answer, as the first answer in the death box, including the sign that it has. And that's going to be your sign and your number in here. A lot of people confuse this, okay? Remember, you're using this as it is. And then I'm going to go 20 times 20 to get that common denominator. So this becomes negative 49 over 20 minus 400 over 20. And that just becomes, oh, there we go. Gosh, that disconnected for a second there. This is now 5x plus 7 over 10 squared. And this is minus 449 over 20. Which cannot be reduced anymore. And the max value, or sorry, the min value, because this is a positive equation, aka the vertex, is going to be at negative 7 over 10 and negative 449 over 20. Yay! Okay, you guys. Okay, so now that we have this, if that person who sent in the original question still has more questions in this vein, let me know. If not, we're going to go back to doing sine and cosine law, just because that should be enough time. The next 15 minutes should be enough time to get another question done. But again, like I said, if you're still struggling, let me know. Okay. So, again, with sine and cosine law, I find that most people lose the biggest amount of marks just by not drawing stuff properly. And that's really unfortunate. Not drawing stuff properly, but also labeling stuff properly. So it's very, very important that you slow yourself down, even if you're very good at math. It's easy to mix things up, and it's not worth losing a mark by rushing. So an engineer is asked to calculate the width of a river. He takes a sighting from point X and another sighting from point Y, both on the shore of the same side of the river, to a point A on the opposite shore of the river. The engineer's measurements are shown below. Okay, so let's take a look at this diagram I'm going to draw. Let me just make this a little bit. This is a much more straightforward diagram than the last one we looked at, so hopefully that's helpful for you guys. Okay, so I'm going to put that triangle in. Again, we're assuming that this is not a this is a non-right angle triangle. Move this over. But just because it's a non-right angle triangle doesn't mean that you can't create a right angle inside of it. So usually what we would do is say to ourselves, okay, this, by cutting down the line straight here, one side actually does have a 90-degree angle inside of it. Okay, not the point though. So let's put in our drawings. So this is the river. We're trying to get the approximate amounts here. So this is X. Let's use colors just to make things a little bit poppier. So we've got X here. This is Y. Again, my drawing of the riverbanks is not perfect, you guys, but just bear with me here. Great, and then let's put this, this is the width of the river. Here we've got 46 degrees, and here we've got 54 degrees. And from here to here, it's 250 meters, as it says in the question. Or actually, it doesn't say in the question, but this is given in the question. Okay, guys, so let's talk about what's important here, what we actually care about, and what we're looking for. So again, whenever we're given a question like this, we want to ask ourselves, what has been given? What do we need? That's really always in math, really the main thing you want to say to yourself. What have I been given and what do I need? So he's been asked for the width of this river. And there are a couple ways to measure this. And this is actually a kind of recurring physics question that if you do take physics in university, you will get questions like this. So it's important to understand how this works. Now, in general, teachers and profs and everybody expect you to label things a certain way. Okay, so for example, this side length is side length AY. This side length is side length AX. This side length is side length XY. It's very important that you do this labeling in the beginning. It just makes life a lot easier. So in this case, we ask ourselves, should we be using cosine law or sine law, right? Because we're trying to find out what the lengths are. And realistically, we want to solve for pretty much all the side lengths of this triangle. So in this case, I'm going to say to myself, well, typically when I have some angles and only one side length, my best bet is to go ahead and solve using the sine law. And in the sine law, we can switch it. So it can either be written as sine of alpha or sine of A, angle A over A equals sine of angle B over side length B, or you can write it as side length A over the sine of A equals the side of B over the sine of B. The side B over sine B. I know that's confusing, but it's a proportion, it's a ratio, right? It can switch and flip. It doesn't really matter which way you put it. And actually, we just did proportions in the grade 9 class, like in the first hour today. So if you're confused by this, just feel free to watch the video that's going to be released later, and you're more than welcome to take a look at that. So anyways, in this case, remember from last week I was saying whatever it is that you're solving for should go in the numerator. So in this case, we're solving for side lengths. And that's really important to understand. Now, I'm going to get rid of these letters because we need to use the letters in play for this question. So, ask yourself first, what side is across from what thing? Okay? So, the sign of XAY, so I'll show you what I mean, wherein we know that this angle, sorry, before I jump ahead, this angle we know has to be 80 because obviously 46 plus 54 is 100, and then 180 minus 100 is 80. And we know that all three angles need to add up to 180. So we know this angle, and we know this side length. So that's obviously what we need to keep in mind in terms of what we're using. So remember how I said we're searching for side lengths? Well, that's really important. So side length xy over the sine of angle xay, and remember that middle thing, the middle letter is going to tell us which is really the angle that we care about. So this is angle xay right here, because it goes xay. The apex of that triangle, of the angle, is the a. Is going to equal, and then we're going to pick some other length. And in this case, we're going to care about side length AX. So that means that we're going to use the sine of 54. But first, we're going to write this out as side length AX over sine of angle X AY. Actually, hold on a second, you guys. It should be XYA. There we go. Okay, so let's go ahead and plug everything in. So we've got 250, because that's the length of XY, over the sine of 80 equals some side length AX that we don't know, over the sine of 54, because that's the opposite side. Okay? Now, for those of you who might have missed last week, now we're just going to do a cross multiplication. So I'm going to get, typically I would recommend to people just do this and don't put decimals in your answers until the very end. It just confuses people. A lot of people ask me, can I cross the signs out here? Be very aware that you cannot cross signs out. Sine is a function, and it's actually doing something to 80. So the sine of 80 is an answer. The sine of 54 will give you an answer. So anyways, I'm going to go ahead and plug this in. So 250 divided by sine of 84 times the sine of 54. And we're going to get 200. Oh, 1 second. $205.37. So A of X is approximately equal to 205.37. So that's this right here. So let's plug that in. 205.37 meters. Wonderful. And then you can very easily solve for the other side using the same sine law. So, or you could just go ahead and use your trigonometric identities, which is no problem. Either way, it's fine. So here, if for this, we're solving for sine of angle X is equal to AB over AX, because this is B right here. This right here is point B. So what we're saying is realistically this width over AX. The reason is because if we have sine of 46, the opposite is AB, which we don't know. So I'm going to call that angle X. And then AX is 205.37. And then I can just cross multiply again. So I'm gonna put that by itself. There we go. So this becomes 205.37 times the sine of 46 equals x. And that gives us approximately a width of approximately 147.73. Yay! Great. So the width of the river is, to the nearest tenth, 147.7 meters. There we are. So this obviously had a couple different ways of solving. You could have done another sine law for this. Not another sine law, but you could have done the other side. It doesn't really matter how and where you solve. It just matters that you use your logic to get to the final answer. So a lot of these trig problems are going to have multiple ways of solving them. It's just important to remember the basic rules so that you can apply them in a way that makes sense. Okay. So basically, that's everything. I'm going to leave that up for a second. That's everything for today. So that means we get to wrap up a couple minutes early. But if anyone has questions, I'll just wait here for another minute or so. And you can either drop your questions in the chat for me to quickly answer before we got to go. Or feel free to email them to us at admin@scholarlyelite.com, and we can answer them for you next week. Okay? So we only realistically have 3 more weeks of freemathhelp.ca live streams going on before the end of the school year, because you guys aren't having exams this year. So if you do have any questions, you're welcome to let me know, because obviously we're going to be wrapping up grade 10. And for those of you who are taking grade 11 next year, I actually really recommend going in and watching our grade 11 live streams. They're on our YouTube channel. You can definitely start working ahead on the grade 11 curriculum. Our tutoring, so we obviously are a tutoring company. We actually do a lot of pre-teaching over the summer. So we actually, in advance, will teach you the grade 11 curriculum so that when you get there to your grade 11 class, you already know everything and you're 10 steps ahead. That way, if you ever have to miss class, or if you have a teacher who doesn't explain things well, you already know everything and you're literally 10 times more likely to do well. So yeah, so if you are interested, we have online tutors working around the clock, working around your schedule. So if you would like, just go to scholarlyelite.com and request a tutor, and we will get in touch. Okay. Other than that, I wish you all the best of luck. I hope that you're staying safe out there. I hope that you are well. And I will see you again next week. Same time, same place. Thank you guys. Have a great day, okay? Have a good one. Bye.